Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hi everyone. Welcome to this series, which is Introduction to Dynamic Programming, wherein we are going to start our DP series, and we will be covering all the sessions, all the topics that are covered in DP. So, welcome to the first day of this series, and I hope my voice is audible. So, can I please get a quick confirmation for that? And also, if my screen is clearly visible. Yeah. All right. Thank you. And also, very happy new year to all of you. So we are here. Let's just wait for a couple more minutes so that rest of our friends also join. And then we will be beginning this first day of the series, that is dynamic programming. And this is introduction to dynamic programming. Hi Rish. We will be beginning in just a minute. All right, we will be beginning at 5:22:05 so that rest of our friends also join. Hi Priya, hi Shivam. All right, so my voice is clearly audible, right? That's nice to hear, Shivam. Okay. Thanks everyone for confirming. All right. So let's begin. Thanks, Jyoti. So we are here with the first day of our dynamic programming series, and the first day, that is what we are going to discuss, is that is introduction to dynamic programming. Yes, exactly. Everything that is in your mind will be taken care of. And as it is the first day, so whatever all of you are expecting from this series, okay, we will be taking all that into consideration. And then on the basis of that, the entire series will be framed. All right. First of all, I will be discussing my plan, that how I'm planning to take up the series. And then if any of you is having any suggestion, then you all of you can let me know. And then we will move ahead with that. Okay. Now, first of all, let us start with what exactly is DP. Okay, so what is one thing that is said very famously about DP is those who don't remember the past are condemned to repeat it. All right. So the entire dynamic programming is based on this intuition. Okay. And this intuition is those who don't remember the past are condemned to repeat it. All right. So basically, in DP, what we are going to do is the thing that we have already evaluated. All right. The value that we have already generated, we are not going to re-evaluate it again. Okay. So basically, the thing is that DP is basically an optimized approach wherein we store the evaluated value so that we don't need to re-evaluate it again. Okay. So, okay, this means that whatever value, those who don't remember the past are condemned to repeat it, which means that whatever has happened in the past, if that is not stored anywhere, all right, if you are not having its stored value, then what you will have to do is that you will have to repeat it again. Okay, now today is the first day. So the one question that is going to be our reference in the entire series, that is Fibonacci numbers. Okay. Hi, Nikaj. All right. So everyone, okay, let me add few more things about the series as well. So what are we going to do in this series is beginning from today, okay? This series is going to last for 15 days, all right? Now, in 15 days, what we will be doing is we will be taking all the problems that are based on the DP, and then we will be doing we will be clearing the concepts that are based on DP, and then based on those concepts, the questions that can be derived from those concepts, we will be discussing them as well. Okay. For example, there are few parent questions, right? For example, we have 0 1 knapsack, right? Then we have unbounded knapsack. And what another kind of knapsack that we have? Can anyone help me with it? Yeah. Okay, so we have one more kind of a knapsack, and that is okay, let me check if we have an answer here. Bounded. That is fractional knapsack, all right? Okay, so what we are going to do is, okay, so 0 1 knapsack that is taken into consideration. Then we have unbounded knapsack, and then we have fractional knapsack. All right. Now see what happens is this 0 1 knapsack is a standard DP question, right? But then there are several questions that are based on this 0 1 knapsack, right? So what we are going to do is you need to identify that what questions are based on which concept. Okay, and once that concept is clear to you, you will be able to apply this approach, right? Let us see, you are now very much clear about what is 0 1 knapsack, what is unbounded knapsack, what is fractional knapsack. Okay, now once when you will practice the questions that are based on these concepts, then you will be able to understand the applications of these concepts as well. Okay, so that is how this series will be continued. Like, first of all, we will be discussing the concept. Okay, by concept what I mean is parent problems. Okay, parent problems based on DP. Okay, so first of all, we will be doing parent problems based on DP, and then what we will be doing is we will derive the questions based on parent problem. Okay, For example, let us say we are discussing knapsack, that is a parent problem, and then one question that is based on this parent problem is target sum. All right. So anyone, like this is the plan that we are going to follow. So if anyone is having any suggestion for this, or if they need any modification in it, do let me know. All right. For example, knapsack is a parent problem, LCS is a parent problem, right? And then we have MCM as a parent problem. Then we have cadence Selgo. And then it comes, we have DP on grid. And then we have DP on trees. Like there can be many parent problems that are there. So one by one, we will be discussing all of them. Okay. And then we will be doing the questions that are based on these parent problem. Yes, exactly. DP on strings. Thanks, Nikaj. That will be also taken care in this series. Now, what is this? DP is actually a practice concept. All right. Whatever theory I am all going to tell you, unless and until you will not practice it, you will not get clear hold of what is the approach behind the questions, right? So rather than just doing the theoretical part, or rather than just explaining the concept, we will be doing hands-on practice problems, right? So this is what we are going to do in this series of 15 days. Okay, that is till 24th February. And the timeline for this series is, let me, okay, just a second. All right. So every Thursday and Friday, at 10 p.m. Okay, 2 days in a week, right? Till 24th of February. Is the timeline of this series clear to you all? Or if there is any suggestion for it, any modification, anything that you want, you all can let me know, and I will be adding that in this series as well. Good evening. Okay, so in this entire series, the programming language that we are majorly going to use is C++. And also, if at any point of time you all will require code in Java and Python, then after solving each problem, the Java and Python code will also be provided in the link. But the questions will be majorly solved in C++ only. All right. All right. So we will be going live at every Thursday, Friday at 10 p.m. Okay. And the session will be taken by me. I'm a mentor at Geeks4Geeks here. All right. So what are we going to do is, yes, exactly, Nitish, all of these things will be taken care of. We will be discussing that how, okay, we will be discussing on how we need to, how we can identify that if a question belongs to which parent problem. All right. That all will be taken care of. We will be starting from a very basic concepts. Then we will be moving to the intermediate concepts. And then, of course, we will be moving to the more advanced concepts. Okay. All of these things will be taken care of, right? Now, first thing, as I said about DP, those who don't remember the past are condemned to repeat it. So what does that mean is, what we are basically going to do is, we are going to store the calculated values. Okay, that basically what DP is. Okay, just store the calculated values. All right. Now, can anyone tell me what is the parent of DP? Like DP is derived from one approach, like which approach was failing, because of which we needed to come to DP. DP is an optimized solution, we all know, but an optimized solution for what? For which approach? Exactly. That's correct. DP is an optimized solution for recursion, which means you can say that DP is optimized recursion. Okay. See, for greedy, it is DP and greedy are completely two different concepts, right? If in a question you are using greedy, then you can't use DP there, right? So both of them are completely different, but the parent of DP is recursion, okay? We have recursion and then, yes, so recursion is a very important. Yes, exactly. So DP is the optimized recursion. Okay. So as we know, whenever you do a recursive call, right? Let me. Yeah. So whenever we make a recursive call, what is the time complexity of a recursive call? Can anyone tell me what is the time complexity of a recursive call? All right, and let us say, okay, linear, that is correct, everyone. But let us say it is in the recursive call, we have in the recursive function, we have two recursive calls. Then what will be the time complexity for that? Exponential, exactly. So the thing is, for recursive code, see, the time complexity of recursive code is exponential, okay? So that is quite a big time. All right, right, everyone, that's the correct answer. Now, what will be the time complexity of DP approach? Yes, exactly. So the time complexity of a DP approach is a linear one. Okay, so that is how, like the standard DP approach, it will take a linear time. Okay, but there are some other versions of DP as well where it can take more than linear time. But here we are discussing the standard approach. So in a standard approach, we will be having a linear time complexity, but for the recursive code, you will be having an exponential time complexity. So as you can see, DP is thus optimized recursion. All right. Right. Now, let me explain you more facts. How to identify if a problem is a DP based. All right. So I want all of you to answer it in the chat section. How you can identify if a problem is DP based. Whatever is coming in your mind, all of you can add it in the chat section. Overlapping subproblems for DP. All right. Okay, Nikaj and Faisal, we have different choices. That's correct. All right, Suraj, we have to calculate minimum and maximum, which means the optimal solution that we are looking for. All right. So, okay. There are certain factors that are there in a DP question. And now what are those factors? All right, Sahib, that doesn't need to be a necessary condition. Sometimes a very smaller question can also be solved with the help of DP, having small sentences. So first thing is that in a DP question, there will always be overlapping subproblems. Okay. What do I mean by, okay, there are two terms here. First is overlapping, next is subproblems. Now, first of all, let us analyze what is overlapping. Okay, so the reference question that we are going to take today, that is Fibonacci numbers. All right. Now, in Fibonacci numbers, what happens is, all right, let us say we need to calculate the Fibonacci of 5. Okay, there's this function and the function wants us to print the fifth Fibonacci number. Okay, now how are we going to do this question? Okay, so everyone is familiar with Fibonacci numbers, right? Now, first of all, let me write the recursive code for this. If we have a function, say, int Fibonacci, and it is taking an integer n, okay? Now, tell me what is, okay, in recursion, what is one most important thing that we need to take in mind? Recursion is having, every recursive function is having a most important thing, right? If you will not add that important condition, then the recursive function will fail. So what is that condition? What's that condition is called? Base case, exactly, Faisal. So tell me what will be the base condition for this Fibonacci number? Yes, exactly. That's the base case, right, everyone? Naikat, Santosh, Mahi, Yuresh, every one of you are correct. Okay. Now tell me what will be the base condition for this Fibonacci number, for this Fibonacci function that we are going to calculate using recursion. Okay. So if n is less than is equal to 1, return n. Clear? Exactly. Gautam, Naikaj, all of you are correct. Very happy to see this. Yes, Dharmendra. So if n is less than is equal to 1, we will be returning n. Okay. And if it is not so, then what we will be returning? We will simply return Fibonacci of n minus 1 plus Fibonacci of n minus 2. All right. Is this code snippet clear to all of you? Let me know in the chat section. It seems like it is clear, right? Quite a simple code. We all have went through this code quite large number of times. So very simple code, okay? Now let us say what we want is, okay, clear. So let us say, now let us say we want to calculate the Fibonacci of 5. So how it will look like, let me draw the tree. Okay, let us see, let us say we want to calculate Fibonacci of 5. Okay, now for that, what are we going to do is, yeah, n minus 1, that is Fibonacci of 4, n minus 2, that is Fibonacci of 3. The recursive function will be calculating these two. Clear? Now again we have Fibonacci of 4. For that, n minus 1 will be Fibonacci of 3 and n minus 2 will be Fibonacci of 2. For this, n minus 1 will be Fibonacci of 2 and n minus 2 will be Fibonacci of 1. Cool? For this, again we have Fib 3. Here we will have Fibonacci of 2, Fibonacci of 1. Okay. Here we will have Fibonacci of 1, Fibonacci of 0. Okay. Here we will have Fibonacci of 1, Fibonacci of 0 again, and as it is 1, so it will be returning 1 only. So there is no any subtree that is going to be generated here. And then again for this Fibonacci of 2, we will have Fibonacci of 1 and Fibonacci of 0. Okay. So is this tree clear to you all? Let me show it in the entire screen. Yeah. Is this recursive tree clear to you all? Like how the recursion will be called again and again if we wish to calculate the Fibonacci of 5. All right. So now tell me how many overlapping subproblems are there that is visible to you. Okay. See, here we are calculating Fibonacci of 3. Here again we are calculating it. And then, all right, nowhere else. So let us now use a different color. Here we have calculated Fibonacci of 2. Here again we are calculating. And here again we are calculating. Okay. And now, okay, so we are calculating Fibonacci of 1 here, 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 here. Okay, and here as well. All right. So are you able to see the overlapping sub problems? That is, the value that we are calculating again and again. See, Fibonacci of 3 has been calculated here already, but then still again we are calculating it here. Similar, the Fibonacci of 2 has already been calculated here, but still again we are calculating it here as well. We are calculating it here as well. So this is wastage of time and space, right? And that is something that as a good software engineer we must avoid. Cool. So that is why recursion DP comes into the picture. Okay. What DP will do is, okay, just a second. Yeah. So what DP will do is it will store the value of calculated value, say, okay. All right. So what it will do is it will remember the value that has already been evaluated. All right. So basically what it is doing is it is doing the memoization. Okay. Which means remembering the calculated values. Yes, exactly. Pre-calculated values, we can say. All right. So that is what DP does. Okay. So is every one of you justified that why we need DP while we already had recursion? Why the need of DP occurred? Is this need of DP clear to all of you? Yes. So this was the first condition, that we had overlapping subproblems. All right. Next is what happens in a DP is there is always a choice that is to be made. On this basis as well, all right, there's a choice that is to be made, and on this basis as well you can identify if the question is DP based or not. So by overlapping subproblem means if ever there is a question where you see that same value is getting calculated more than one time, then in that case you can safely say that the problem is DP based. And another thing, if there's a choice to be made, for example, we have this 0 1 knapsack, very famous problem. Now, what happens in this knapsack is there's this bag that is given to you, okay? And then you need to find out, like there are certain ways that is given. You need to find out whether you have to add this weight or whether you have to not add this weight, right? For every weight, we calculate this. For every value, we calculate this, and we have a limit on weight. Okay, so that is what it means, that we are making certain choices, right? For example, we have this LCS question as well, longest common substring, longest common subsequence, right? These are the certain things that we have. Here also we need to decide, like suppose the string that is given to us is geeks for geeks. Yes, Nikers, that's correct. In 0 1 knapsack we use 2D DP. So, okay, let us say the string that is given to us is geeks for geeks. Now, let us say here also we need to make a choice at certain point of time, that whether we need to add this character in our answer string or not. All right. So these are the choices that we need to make at several steps. So whenever there's a choice involved and you need to find out what is the most optimal choice, okay? Need to find most optimal choice. Then in that case as well, we use DP. Okay. So is the problem identification clear to you all? The two cases that we had. Okay. There must be overlapping subproblem, or if there is a choice that is to be made. Okay. If these two things are there, then you can safely say that the problem is DP based. Are these two things clear to you? Okay. All right. Now let us see how DP works. Okay, so basically the DP is remember your past. All right, this is the meaning of DP. In Fibonacci, there is no choice, but in Fibonacci, we have overlapping problems. Okay, there is not and between this, it is or. Okay, if at any problem you find overlapping subproblem, or if there are choices that are to be made, then in these two cases, you can say that problem is DP based. All right, Ritesh. Okay, so now basically the DP is remember your past. Now let us discuss about what are the approaches that how the code of DP flows. The first step is write a recursive approach for a solution. Once you have written this, then move to memoization. And once done with this, then form DP table. All right. It can be either in a top-down way or it can be either in a bottom-up. Any of the fashion you can use. Okay, it will form a table. Okay. This is called tabulation method. Exactly, Faisal. Okay, so these are the three steps that are being followed to write a DP code. All right, first of all, you need to write the recursive approach. In whatever there is in recursion, you need to memorize it. Okay, and once you have done this, then we need to have a tabulation method. Okay. Okay, recursion, memoization, tabulation. All right, these are the three steps that are involved in DP. Clear? Now, we have discussed the recursive approach for the Fibonacci. Now, let us here see how we can proceed. Okay. How we can proceed with the code of Fibonacci number. All right. So this recursive code is clear to you, right? Now, we are going to write here a DP code for the Fibonacci. Now, I want you all to help me out with that. Okay, so in Fibonacci, let us say int n is given to us, all right? Now, okay, what is the first step that we are going to do is, for DP, you need to have a table. Let us say we are creating a table of size n plus 2, okay? Now, what we need to do is, just start the loop. For the base condition, what we are going to do is f of 0 will come out to be 0 and f of 1 will come out to be 1. Okay. Now, for I is equal to 2, I is less than is equal to n, I plus plus, okay. How we are going to fill this table? F of I is equal to, okay, let me show you the recursive code. Okay, so what we are adding is Fibonacci of n minus 1, Fibonacci of n minus 2. Okay, so simply f of I is equal to f of I minus 1, f of I minus 2. Okay. Yes, Rajat, definitely it is one of the scariest topic, and in this series we'll try our best to simplify this topic for you so that you can have a strong hold over this concept. Okay, and then once we are done with this, we will simply return f of n. Okay, so this is the DP code. Basically, it is using a tabulation method. Okay. You're most welcome, Rajat. Just make sure that you are following this series and then we'll try our best to help you out. And also, if there is any consideration, any modification that any one of you wants to add, all of you can add it in the chat section. We will take that into consideration. All right. Okay, so this is the tabulation method that we are following for the Fibonacci numbers. Okay. Now, what is the time complexity for this code? All right, Faisal, we will be taking up the 2D DP questions as well, like LCS. That is also a parent problem, and many problems can be derived from that problem as well. So that will be taken into consideration. Okay, so what will be the time complexity for this code? Log n. Okay, so time complexity is going to be the linear. Okay, so in the like whatever in the recursive code, the time complexity was exponential. Okay, and here we have for the DP code, the time complexity is linear. All right. Okay, whatever has been discussed till now, is everything clear to you all? Why we are using DP? What are the processes by which we can identify if a question is a DP based or not? And how we are going to derive the DP approach to a question? First recursion, memoization, then tabulation. Are all of the concepts clear to you all? Okay. All right, guys. So exactly, Nicholas, that's correct. You need to find out that how many variables are getting changed. Okay. So if more than like whatever the number of states are getting changed, you need to have a table with that dimensions. And in some case, we need to have a 3D DP as well. That are also the conditions. Okay, so first of all, we are clear on how we can classify if a problem is a DP problem or not. And then the second step that we are going to follow is we need to find the state that are getting changed. Okay. So the number of states that are getting changed, that will be the parameter. That will be the dimensions of our DP table that we are going to form. And also you need to find out that, the next step and the previous step. Okay. Whenever we do a step, what happens is that a state is getting changed, right? So you need to find out that what is the relationship between the previous state and the current state. Okay. All right, Faisal, we will be helping you with that. And once the relationship has been formed between the previous state and the current state, then on that basis, you can simply write down the code. Okay. That will help you with it, right? And then you can add the memoization or tabulation simply to optimize it. So every problem that is there, all right, let us say subset sum problem, edit distance problem, cutting a rod problem, every problem will be discussed in this series. So okay, that is pretty much what I have to discuss about DP in today's series and why we are using it. Okay, everything about it. So all right. So that is all about our DP series for today. And the timeline that I have discussed, we are going to follow that timeline only. So, all right, if there is any suggestion, any doubt, every one of you is free to ask it. Let me know it in the chat section. We will be taking up the questions. The question links will be given in the question links will be given in the description of this video. Okay, and then all of you can access the questions from there and you can try to solve it. And also in the session also we will be solving the questions. Thanks, Nikaj. This gives me motivation to try to give the best to the series. All right, Faisal, that's completely up to you. You can use whatever approach you want to do, top down or bottom up. And also, if you want a detailed analysis on this top down and bottom up. So, all right, okay. So, okay, so DP is having two type of approaches. Okay, it will be one will be top down approach and another will be bottom up approach. And then in top down approach, what happens is basically you need to identify in both of these approaches. What we are doing is we are breaking a larger problem into smaller sub problems, right? So whatever approach that is coming into your mind first, if you are able to write down a code for it, if you are able to form a table for it, that is completely correct. Okay. All right. So, okay, anything else that anyone want to add for this session? And also there's an article whose link I'll share with all of you so that all of you can go through it and then have a good grasp over the DP concepts before we start. Let me add it in the comment section. All right, everyone. So this is an article that is there for dynamic programming. I want all of you to go through this article so that all of you can have an idea about what we are going to discuss in this series. Thanks, Harshit. All right. Anything else anyone wants to add? Okay, so all right, that is all about this Fibonacci, the first day of this series where we got an introduction on what we are going to do and we saw a timeline on how we are going to cover all the topics of this DP. So all right, let me just, okay. So yeah, thanks everyone for attending this session. Let's begin this series with lots of enthusiasm and lots of hard work, lots of practices. We will be doing, lots of exciting things in this entire series. And I wish all of us have a good learning after the end of this series. So yeah, that it is an introductory series and we discussed about the timeline and we discussed about the importance of DP, like how we can identify if a problem is DP based and why we needed DP. All right, all of these things we discussed in this session. In upcoming sessions we will be taking up questions one by one. All right, we will be solving the parent problems and then we will be solving the problems that are derived from those parent problems. Okay, so that is all that we are going to do. And thanks everyone for attending this session. All right, and good night everyone. Keep up the hard work.